Yes, in previous class, I completed this one statistical time division multiplexing. Then I'm going to talk about spread spectrum. The spread spectrum. The main goal of this method is uh, to provide the privacy and handy jumping methods. And before that, it is going to added the redundancy. Okay, why it is the redundancy will be happen here means we are going to protect our original signal means the source, the receiver, the source and receiver, it is going to communicate between the, or it is going to transaction the original signal, that we have to prevent it means we have to give more secure, secure, so that we are going to adding the redundancy here. Then the each station or each device, we require the bandwidth. So here the bandwidth is very important. We have to expand the bandwidth in this spread spectrum. So each station having the bandwidth, we consider as a b here, and the spread spectrum bandwidth we consider as a bss, such that bss means spread spectrum bandwidth is very very greater than of the given original bandwidth. Means here we have to expand the bandwidth to allow the our original message to protect our secure transaction. The next one is the it is going to work over two goals, our spread spectrum. What are the two goals, or what are the two principles here means the one principle, the first principle is the bandwidth allocated each station means each station, we supposed to allocated the bandwidth. Yes, obviously we require the redundant means we have to elaborate the bandwidth for each and every devices. So this method, we call it as a redundancy method. The second one is the expanding the original bandwidth B, and the spread spectrum bandwidth BSS. It must be independent of the original signal. The next one, see here, you look at the diagram of the spread spectrum. So this is what the original bandwidth means. This is what the given the each station having the bandwidth is a original bandwidth. This bandwidth, with the help of our spreading code, spreading process, we have to expand our the spread spectrum bandwidth with the help of redundancy. See, now you got the difference. Okay, this is what the actual bandwidth of the each device or each signal. See, once we added the redundancy, or once we applied the redundancy to protect our spread spectrum bandwidth, so we have to expand, or we have to elaborate the that particular bandwidth at the receiver side. Then there are two techniques we supposed to talk about this spread spectrum method. The first one is frequency hopping spread spectrum. The second one is direct sequence spread spectrum. Here, the frequency hopping spread spectrum, it is a technique. It is uses n number of different carrier frequencies that are going to modulated by our original source. Here, see, one time, the first time, the signal, it is going to modulated the one carrier frequency. At the next time, the means another signal, it is going to modulates the another frequency. Means the each and every time the frequency will be changed. The see, this is what the see this is what our see, this is what the diagram of the frequency hopping spread spectrum. Here the frequency hopping spread spectrum, we can use the yeah, so pseudo random generated or code generator. The pseudo random code generator, we call it as a pseudo random noise or PS, we call it as a in short form PS. See this code generator, it is going to create the k bit pattern, means it is going to create the group of pattern. That group of pattern, it is going to matches the frequency, means with the help of frequency table, it is going the like in pseudocode generator, it is having the some group of pattern. That group of pattern, suppose you consider here, I'll show in here. In then see here, so this is what the k bit pattern is. This is what the group of pseudocode generator. So it is having some group of elements. Suppose I'm considered as a 101 here. See the 101, it is going to map with the our frequency table, means the 101, see it is going to map with our frequency table. It is going to provide the 700 kilohertz. Okay, if it is 00, yes, you consider it. So if it is 00, yes, you have to search in this group of bit into the frequency table. See here 00, yeah, we are here 00 here, the first yeah, first place. The 00, it is going to provide the 200 kilohertz. Means what I am going to tell here means, based on the pseudo random code generator, it is going to provide the n number of bits, or it is a group of bit pattern. Based on that bit pattern, it is going to fetch the frequency from the frequency table. That frequency, it is going to send to our frequency synthesizer. That frequency synthesizer, what will do means, it is going to create the carrier signal of that frequency, and that is going to modulated the that is going to modulate our spread signal. Means first of all, initially we are going to pass the original signal. That original signal, it is going to fetch the pseudo random code generator. With the help of pseudo random code generator, it is going to map that particular particular group of bits into the frequency table. That frequency table, it is going to tell from like the some sequence of number. It is going to follow the these many frequencies. Okay, that followed by the sequence, it is going to take these many frequencies. That amount of frequency, it is going to take care the frequency synthesizer. Here the frequency synthesizer, it is going to create the carrier signal of the frequency. That carrier signal of the frequency, it is going to send to our modulator. So our modulator, it is going to modulate the source signals to provide our finally one spread signals. The next method is, the next technique is direct sequence spread spectrum. The direct sequence spread spectrum, it is a DSS technique. Also expand the bandwidth of the original signal. Here, in direct sequence spectrum, here we cannot use any pseudocode random technique or frequency synthesizer or frequency table, nothing. Okay, directly whatever the original signal is there, with the help of bandwidth, we have to expand that particular signal, and finally we have to modulate it that, and we get back the original signal. See this method, we call it as a direct sequence method. The direct sequence spread spectrum, we replace the each data bit with n bit using a spreading code. Means we have to replace whatever the data is there, the whatever the data bit is there, that we are going to replace into another format of data bits. I'll show in the diagram. See, this is what the original signal. So the original signal, our chip generator, okay, our chip generator means the chip generator, it is having the n number of n number of code, means n number of the bit, okay, the particular bit, okay, which data